Hello friends, welcome back to my YouTube channel Career Maker. Today I am sharing a topic on logic. First we know what is logic. Generally logic means a particular way of thinking. Here in case of mathematics, that is a study of method, structure and also gives a conclusion based on the data set. Next we know the definition about proposition. Proposition is also known as a statement. We know for a statement that must be a sentence, and also sentence is of 5 types like declarative sentence, imperative sentence, like this. We know for a statement that must be a declarative sentence. So in case of proposition, that must be a declarative sentence and that is either true or false but not both. Here this is an example of proposition. New Delhi is the capital of India. This is a declarative sentence, so it is a statement. Another example like please help me. This is not a declarative sentence, it is an imperative sentence, so it is not a statement. Like another example, 9 less than 6. Suppose 9 less than 6. 9 less than 6, this is not a declarative sentence. It gives an false value, so it is not a proposition. Next, what is negation? Let P be a proposition and the negation of P is denoted by like this. And that is also read as not P. That is the truth value of negation of P is the opposite of the truth value of P. Next, let P be a proposition. Today is Friday is a proposition. Then the negation of P is today is not Friday. That means the negation of P. Today is Friday is a declarative sentence. That negation means today is not Friday. This is the truth table. Here P is in case of positive sense. Negation P, that means it is a negative sense. P, today is Friday is the positive sense, means true. Negation P, that means it is false. Here P means that gives two cases, that is either true or false. In case of true, that the negation of P gives false value, and in case of false, that gives a truth value. Next, conjunction. Conjunction means that is the compound statement, like P and Q be two proposition. You take another proposition like A, B, like this. Suppose I take P and Q be proposition and the conjunction of P and Q is denoted by like this. This is the symbol of conjunction. Here this is the symbol of conjunction and it is denoted as P and Q. That means here and is the conjunction. That means for a compound statement this is the connector. Here and is the connector. So here P and Q are true and also both P and Q is true. That means in case of conjunction, if both P and Q is true, then our conjunction value means the result gives the true value. This is the truth table. Suppose P and Q are here in case of this, we take P, Q are true proposition. That means here it gives 4 cases like true, 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 false, false, true, false, false. Here P and Q is true, so the conjunction value is true, but in other case that must be false. Next, disjunction. Disjunction. Here in case of disjunction we use the connector like this or. Here similarly P and Q be two proposition and the disjunction of a P and Q is denoted by like this. This is the symbol of disjunction. Here P disjunction Q is false when both P and Q are false. That means if P and Q are false, means P false, Q also false, then P disjunction Q is false. Next, this is the truth table of disjunction. That means true, 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 false, true, false, true, true, false, false, false. Here we say that is P and Q both are false. P and Q both proposition are false. That means if P and Q the two proposition are false, the result of the disjunction value will be false. Next, exclusive. Exclusive. This is the symbol of exclusive. Here P and Q also be two proposition. The exclusive OR of P and Q is denoted as like this. Here in case of exclusive, that is the proposition is true when exactly one P and Q is true and is false otherwise. That means this is the truth table. Suppose P and Q are two proposition. That means four cases are arise. That is true, 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 false, false, true, and false, false. We say if P is true and Q is false, then the exclusive result is gives true. Or if P is false and Q is true, then the result gives true. Otherwise, this is false. Next, conditional. Conditional. This is the symbol of conditional. Conditional is also known as implication. Here P and Q are two proposition. The conditional statement P conditional Q, that means if P then Q. The general form of conditional, that is if P then Q. That means if then form. If then form. This is the general form. In case of the conditional statement, P conditional Q is false when P is true and Q is false and true otherwise. That means this is the truth table. P, Q are two proposition. Here also four cases are arise. True, 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 false like this. Here I say about if P is true and Q is false, the case is false. Otherwise it will be true. Means P true and Q false, then the result will be false, otherwise it will be true. Here we also say the in case of conditional statement, P is called the hypothesis. Here P is called the hypothesis and Q is called the conclusion. Clear? Next, biconditional. Biconditional, that is also known as double implication. Here this is this is the symbol of biconditional. Here also P and Q are two proposition. The biconditional statement like P if and only if Q. That means the general form of biconditional, that is if and only if. The biconditional statement is true when P and Q have the same truth value and false otherwise. If in case of P, Q are two proposition, here P and Q both are true or both are false, then the result will be true, otherwise it becomes false. This say our truth table. Next I give some example question. Here I say, I ask some question like how many rows appear in a truth table for each of these compound proposition. In case of compound proposition, here in case first question I say P conditional negation of P. Here n equal to 1 means here the propositional value number of the propositional value is equal to 1. So n equal to 1. So how many rows are possible? That is the general formula, that is 2 to the power n. So here we know n equal to 1. The value will be 2 to the power 1, that is equal to 2. So here the result will be 2. Next, P disjunction negation R, conjunction Q disjunction negation S. Here 4 propositions are present. P, Q, R, S. 4 propositions are present. So n is equal to 4. So how many rows are present? Our formula is 2 to the power n. So 2 to the power 4, that is equal to 16. Clear? Similarly, I give some other example. You will solve it. These are also similar question. Next question, I will ask to construct a truth table for each of these compound proposition. In first question, P disjunction negation P. For this question, you know how many rows are possible? We know here P means our two cases are arise. So number of row is equal to 2. Here P true and false. So the negation of P become false. When P is true, negation of P is false. When P is false, then negation of P is true. Then I will become clear that P conjunction negation of P. We know in case of conjunction true, but otherwise that will become false. So here P is true and false, then the result will be false. And in case of this, the P value is false and the negation P value is true, so the result become false.